Welcome to today's chemistry lesson, where we will explore one of the most fundamental topics in science, chemical bonding. To understand bonding, let's start with the basics. Every atom is made up of a nucleus containing protons and neutrons, surrounded by electrons that move in energy levels or shells. The electrons in the outermost shell are called valence electrons, and these are the ones responsible for bonding. Now, atoms always strive for stability. They want to achieve a full outer shell of electrons. Most atoms try to follow what we call the Octet Rule, meaning they want 8 electrons in their outer shell, just like the noble gases such as neon and argon, which are naturally stable. Some smaller atoms like hydrogen and helium follow the Duplet Rule, meaning they are stable, with just 2 electrons. When atoms are not stable, they react with other atoms to share, lose, or gain electrons. This interaction is what we call chemical bonding. There are 3 major types of chemical bonds. Let's begin with the ionic bond. An ionic bond occurs when one atom transfers electrons to another. This usually happens between a metal and a nonmetal. Metals have very few electrons in their outer shell, so they prefer to lose them and form positive ions, while nonmetals have nearly full shells and prefer to gain electrons to become negative ions. For example, sodium has 1 electron in its outer shell, while chlorine has 7. Sodium transfers its electron to chlorine. As a result, sodium becomes positively charged, chlorine becomes negatively charged, and these oppositely charged ions are held together by a strong electrostatic attraction. This creates sodium chloride, or table salt. Ionic compounds like this are usually hard, have high melting and boiling points, and they conduct electricity when molten or dissolved in water because the ions are free to move. The second type of bond is the covalent bond. Instead of transferring electrons, covalent bonding happens when 2 atoms share electrons. This mostly occurs between non-metal atoms. By sharing, both atoms achieve stable outer shells. For instance, 2 hydrogen atoms each have 1 electron, and by sharing, both reach a stable configuration of 2 electrons, forming an H2 molecule. Covalent bonds can be single, double, or even triple bonds depending on how many electron pairs are shared. Oxygen atoms share 2 pairs, forming a double bond in O2, while nitrogen atoms share 3 pairs, forming a triple bond in N2, one of the strongest bonds in nature. Covalent compounds are often gases or liquids at room temperature, have relatively low melting and boiling points compared to ionic compounds, and usually do not conduct electricity because they lack free ions or electrons. However, there are some exceptions like graphite, which conducts electricity due to its free-moving electrons. Next, we have the metallic bond. Metals are special because their atoms do not hold tightly to their outer electrons. Instead, these electrons become delocalized, meaning they are free to move throughout the entire metal structure. You can think of it as a sea of electrons surrounding positive metal ions. This sea of electrons explains many of the unique properties of metals. For example, metals are good conductors of heat and electricity because the free electrons carry energy. They are malleable and ductile, meaning they can be hammered into thin sheets or drawn into wires without breaking, since the layers of metal ions can slide over one another while still being held together by the sea of electrons. Metals also appear shiny because their free electrons reflect light. There is also a special case of covalent bonding called the coordinate bond, or dative bond. In this type, both electrons in the shared pair come from a single atom. For example, in the ammonium ion, ammonia has a lone pair of electrons. It donates this pair to bond with a hydrogen ion, forming NH4+. Now let's compare these bonds clearly. Ionic bonding involves electron transfer and produces strong crystalline solids like salts. Covalent bonding involves electron sharing and forms molecules, many of which are gases and liquids. Metallic bonding creates a flexible and conductive structure in metals due to free electrons. Each bond type explains why substances behave the way they do, from melting point and solubility to electrical conductivity and physical strength. In summary, atoms bond because they seek stability and lower energy. The type of bond formed depends on whether electrons are transferred, shared, or delocalized. Without chemical bonding, the universe would not have the variety of substances we see today, and life as we know it would not exist. So whenever you look at water, salt, metals, or even the air you breathe, remember, it is all made possible by the fascinating world of chemical bonding.